because this is a short video talking about how to obtain the projection of a vector onto another vector. So for example, if I give you two vectors, A vector is in blue and B vector in red, and I want to compute the projection of A onto B vector, meaning that I'm going to project A onto B. This is the physical medium by projection. So I'm going to project, assuming that starting with the same common starting point, and I do for the ending point of A vector, I'm going to do a perpendicular line from this point to the B vector, and this vector starting from the common point over here to this projected point over here, that's the project vector of A onto B. Okay, let's assume that I'm using C as the projection of A onto B. So C is projection of A onto B. Okay, so to compute this C as a projected vector, we have to know two things. First one is, what is the length of A? Second one is, what is the unit vector of C? Okay, so let's start with, because the product of the actual C vector is just equals the length of C times the unit vector of C. So that will be the actual C, because C is the vector determined by its magnitude or length as well as the direction, which is determined by the unit vector of C. So let's start with the C as the length of C. The length of C actually is computed by, let's assume that the angle between these two, this is the gamma over here. So the length of C is equal to the length of A time cosine gamma. So that's the length of C. Now the problem is a little bit hard to compute what is this, right? Because I have to compute the gamma over here. So easy way we can do this one is we can just do one small trick, which is A time cosine gamma time B magnitude length, and then we divide by, because these two will be cancelled out, so that's the same as the previous one. So the nice thing for the previous one is this is the dot product of A dot B. Okay, so I don't have to calculate this gamma, but I can use the dot product. So essentially what this means is the length of C is A dot B divided by the length of B. Okay, alright. Okay, now this is done with the length of C. So how about the unit vector of C? Because the C and B, they have the same direction, right? They're moving along the same direction, they are the same. So the unit vector of C is also the unit vector of B. Also, because I don't know C, so I don't know what is the unit vector of C, but I can compute the unit vector of B, which is just B divided by B, the length of B. So that's the unit vector of B, right? So we already obtained the length of C and the unit vector of C. So now we can calculate this. This is just A dot B, the dot product of A and B, divided by B length time the unit vector of C, which is B divided by B magnitude, the length of B. So that's how we compute the projection of a vector to another vector. Okay, so here's a very simple example. Let's assume A is 1 or 2, okay, and my B vector is 2 and 1. Okay, let's compute the projection of A onto B. Okay, according to what I said over here, the projection compute the projection of A 2b. So I denote it by c vector. Okay, so as mentioned before, c vector is given by a dot b divided by the b magnitude and time b and divide by b magnitude, which is length of b. Okay, remember the dot product is just the dot product is computed by a dot b. So a dot b is the entry-wide product of the two, so which is 1 times 2. This is the product of the first two. The first is the first entry of a, and the product of the first entry of, and the first entry of b. You get it over here, and then you compute the product of 2 and a 1. So this is then you do plus 2 times 1, and divide by the length of the b is square root of 2 squared plus 1 squared. It's each entry you take a square, and you compute the sum, you take a square root. Okay, and b is, you just repeat the b over here, is 2 and a 1, and this is square root of 2 squared plus 1 squared. That's the same thing. Okay, so this is 1 times 2 plus 2 times 1, so this gives us 4, and this is square root of 5 times 2 1 divided by square root of 5. So I have this square root of 5 times square root of 5 gives us 5, so it's 4 over 5 times 2 and a 1. So that's my projection.